problem, the region is bounded by the y equal to x square. So and y equal to square root of x is given, and it forms a basis of solid. So for this solid, each cross section perpendicular to x-axis is square. So what is the volume of the solid? Okay, so we have the two curves y equal to x square. So y equal to x square is basically a parabola. So this one is the y equal to x square, and y equal to square root of x. So this is the radical function. So this one is y equal to square root of x. Okay, and the forms the base of the solid. So this is the base of the solid. Let's say the region is R. So this one is the base of the solid. For each cross section perpendicular to x-axis is square. So this one is the, so the base is the square. And what is the volume of the solid? Okay, so let's say here the base of the square equal to b. So here b equal to the difference between the top curve minus the bottom curve. So here the top curve is square root of x minus the bottom curve is x square. So this is the base. Okay, so now we have the a square, so whose side length is b, right? So now the area of this cross section A equal to b times b, that is the b squared. So that is, what is b? B is actually square root of x minus x square. Sorry, square root of minus x square. So this is the b, and we have to do whole square, right? So since it is in terms of x, we can rewrite it as a of x equal to square root of x minus x square whole square. Okay, so this one is the area of the cross sectional area, cross section square. To find the volume, we have to accumulate all these squares from here to this point to this point, that is x equal to 0 to x equal to 1. Okay, so the volume equal to volume v equal to integral 0 to 1 a of x dx. So that is integral 0 to 1 a of x equal to, so that is the square root of x minus x square whole square dx. So this is the volume integral. Okay, yes. Now we can use our integration methods to evaluate this integral. So let's do. So we have v equal to integral 0 to 1. So we have the, sorry, we have square here. So that is equal to, we can now first simplify this one. So that is the square root of x whole square equal to, so square root of x minus x square whole square is, so that is the formula we can use, a minus b whole square equal to a square minus 2ab plus b square, right? So here, so a square is, this one is a and this one is b. So a square is, that is root x whole square minus 2 times ab. Ab is, that is the square root of x times b is x square minus b square is, sorry, plus b square is, that is the x square whole square. Okay, so times dx. Okay, simplify this one, integral 0 to 1. So this one is square root of x whole square is x, and this one is 2 times, so we can rewrite this radical as a rational exponent, that is a 2 times x power 1 half times x square plus x to the power, so x square whole square is x to the power 4 dx. and this can be written as integral 0 to 1 x minus, so 2 times, so when we have the same basis, the powers are, the exponents are added, so that is the x power 1 half plus 2, that is the 2, that is the 1 half plus 2 plus x to the power 4 dx, and this one equal to integral 0 to 1 x minus 2 times x power 1 half plus 2, that is x power 5 half, right, plus x to the power 4 dx. So now we have the one formula, integral x power n dx equal to x power n plus 1 over n plus 1 plus c, right. So I apply this formula, so the integral of, okay, let's apply the formula here. So let's apply the formula. The integration of x is, this is the x power 1, so that is the x power 1 plus 1, so that is the x square over 2, minus here 2 is the constant, and x power 5 half is, the integration of the x power 5 half is x power 5 half plus 1 over 5 half plus 1, plus the integration of x power 4 is x power 4 plus 1 over 4 plus 1, and the limits are, we have to substitute the limits, integral 0 to 1. Now we can simplify this one, integral x square over 2 minus 2 times, so this one x power 5 half plus 1, so that is the 7 half, right. So x power 7 half over 7 half, that is over 7 half here, plus here x power 5 over 5, okay. So now this one equal to, so the integral x square over 2 minus, so this is the fraction in the denominator, so we can rewriting it by flipping the fraction, so that is the 2 times, so say 2 over 7, that is the 4 over 7 times x power 7 half plus x power 5 whole power 5 and 0 to 1. And when you substitute the limits, so this is 1 square over 2, when you substitute the upper limit, this is the 1 square over 2, so that is the 1 half minus 4 over 7 times 1 power 7 half is just 1, plus 1 power 5 over 5, that is just 1 over 5, and if you substitute the lower limit, minus of, this one is 0 and this one is 0 and this one is 0, the overall is 0, and this is equal to 1 half minus 4 over 7 plus 1 over 5, and we have the LCD is 7 5 35 35 to 70 is the LCD, so we can rewrite this fraction as a equivalent one, so that is the 35 over 70 here, 40 over 70 here, um, 14 over 7, right. Now we have the common denominator, that is the 70 equal 70, and we can add the numerators, that is the 35 minus 40 plus 14, and this one equal to, so 75 minus 35 minus 40 is minus 5, and minus 5 plus 14 is just 9, right, 9 over 70, okay. So this is the volume of the solid.